All right, ladies and gentlemen, we're about to resume. So all technology please be placed away, safe and sound. Earphones out, everything put away properly. Yay! And we have, oh yeah, detail.
Not going to go through my history section.
I think you can do it.
Probably not as well. All right. I'm Amy Hertig. I am an industrial engineer at Intel. I've been one my whole time. So I'll just kind of kick into it. I'm going to talk specifically about industrial and manufacturing engineering, which are essentially the same thing. But you could hear it either way. So my background is I was born and raised in Wisconsin. So of course I went to the University of Wisconsin-Madison for my undergrad. Got my BS in industrial engineering 2004, same time as Andrew. At that same time while I was in my undergrad, I did intern for Intel in California twice. So that helped me get a little bit of experience and also learn whether this was kind of the right career plan for me. Then luckily, I got hired into that same job that I interned for when I graduated in 2004. So they hired me in just with my undergrad. While I was there, I decided I would get my master's because Intel helps to pay for that. So I didn't have to fully pay for it myself. And then the University of Wisconsin-Madison has a great engineering professional development program or department. They have an all-online engineering management master's, so you can do it from anywhere in the world. I had classmates all over the world and in all different time zones. So it was good, and as well as even if you were in Wisconsin but traveled for your job, you could still do this program because you can do it from anywhere. That's kind of their selling point. But I got my master's in 2011, and then shortly thereafter I transferred up from California here to Portland for a new job with Intel, but still as an industrial engineer. So that's my background. Now, how did I decide to be an industrial engineer? Right, so you guys have a lot more resources than I had. Like Andrew in high school, I never heard about engineering. Heard nothing. Didn't even know it existed. Right, but I was really good at math and science. So fortunately, my grandfather was an electrical engineer. And just before going to college, he's like, hey, you should look into engineering. And I was like, what is that? Right? So I went to school undecided my freshman year, and I took an intro to engineering course, which was just a 1-credit class you just had to go to. Essentially, they just took attendance. And they had a different speaker come in every week to talk about what they did. So they came from all the different engineering disciplines and kind of told you about their job, what they did, and so you could discern if you were interested in it or not. Right. So I took that course and decided whoa, biomedical. That's what I want to do. Right? Because he was talking about some cool designing new ways to do surgery through orthoscopic and all this stuff, right? And so I was like, I need to go talk to a biomedical professor to see if this is right. So I talked to my counselor and he gave me a name of a biomedical professor to talk to, but then he also was giving me all this information about industrial engineering. And I was the whole time in his office, I'm why? Why do we keep circling back to this IE stuff? I'm not interested in that. Came to talk about biomedical, that's what I want to do. I have this all figured out. So I went in and talked to the biomedical professor, and I was like, well, this is not what I want to do. He was like, oh, to do that stuff, you probably more want a computer science degree. And I was like, not computer science, I'm not savvy, not my thing. And I don't want to work in a lab. And biomedical was a lot of specimens, time in the lab, and I was like, that just doesn't sound appealing to me. Right? So I was like, okay, business it is. So I then applied for the school of business. Went home for the summer. Just as I was packing up to come back to school, I was going through all my stuff to repack, to bring it back. And I found all that industrial engineering information that counselor gave me. And I was actually like, okay, well, that's just, what is this really? Right? So I paged through it and I was like, this actually could be perfect for me. So 2 weeks before the semester started, switched, was now gonna go pre-engineering, and I was gonna do industrial. And that's where I've stayed ever since. So like I said, I'm an industrial engineer in my current job, have been all the way through Intel. It's a good fit for me, and I'm still doing it, so obviously like I'm still enjoying it, right? So kind of a random way of getting there. First not knowing anything about engineering at all, and then my counselor just happened to talk about industrial engineering to me for whatever reason. Probably because I kept saying I was business or engineering, and IE is very much like that link between business and engineering. So it was the perfect fit for me. So what is industrial and manufacturing engineering? Essentially, it's efficiency. The easiest way to put it. All you do all day is try to make things more efficient. You want to save the company money, you want to save them time, which inherently saves them money. You want to just take out any inefficiency you can find, right? Companies love that, by the way. So you enter into this continuous improvement cycle, which is pretty much what industrial engineering is. You start with, at the top, identifying the problem, right? So you really have to dig in and understand how they're currently doing the process that they're doing today. Figure out where are the inefficiencies, and then once you have that, you go to the plan stage, which is you figure out how to get rid of those inefficiencies. What kinds of things can you do? Adding automation, adding more people. All these things cost money. So there's also all the constraints of, well, how much money can you spend? How much money does your company have? What can you do today to help things versus what won't come into play until 6 months from now? All those things have to go into your planning stage to figure out really what you want to implement today. Then you go to the execute phase, which is implementing. So whatever you decided you thought at the time was the best option, you want to implement it. And then you review it and see how it went. Kind of like trial and error. You pick something that you think is going to be the best, and you hope it works out. It may not. You may cause a different problem than the one you're trying to solve. So that's where the cycle kind of just always continues, right? You have to re-review it, fix anything that you now cause as a problem or that you didn't see before, because maybe it was masked because the other problem was so much bigger, right? So essentially, industrial engineering is problem solving with optimization in mind. So like all engineering is some sort of problem solving, this one is really like a process driven or like systems driven way of making things more efficient. So we're going to go through an example. Good thing I watered this time. All right, so in our example, we're going to sort mini chocolates. It's a very basic example, but it'll be a good way to kind of get you into the IE mindset. Right. So we have this random bag of 5 different types of chocolates. It's all going to fall off there. And so there's going to be 4 different steps in the process. All right, so step 1, the first person is going to open the bag, walk over to station 2, dump its contents onto station 2. So then station 2 is going to be the sort station. He's going to go through all the randomness of the chocolates and put all the Milky Ways together, all the Snickers together, all the Three Musketeers together, and so on. Station 3 is going to be the count station. So the station 3 person is going to walk over to station 2 and pick up just one candy type at a time and walk it back to his station, and then count out 5 different ones into like each cup. Right, so in the end there's only 5 Milky Ways in one cup. And you can only do one at a time because we can't have any cross-contamination between the different types of candy bars, right? So once they're sorted out, they need to stay segregated. You need to have quality control, so they can only pick up one type at a time. Then station 4 finally is the shipping station. So the station 4 guy is going to walk over to station 3 and pick up one type of candy again because he can't cross-contaminate, and walk it over to shipping and ship it out, right? And then walk back for more. Right, so I'm sure just with those arrows you can see some inefficiencies already, right? But, so as an industrial engineer, your first step is identifying all the problems, right? So the basic step as an industrial engineer is time studies. So everyone has to do it at one point in their career. Typically, you will make your interns do it. Each one of my internships, I had to do lots and lots of time studies. They're not very fun, but you can learn a lot from doing them. So, and there's now, newer ways to do it where you can actually take your laptop into the factory and even into the clean room at Intel, and you can have a program that you can set, and it manually does all the calcs for you and creates everything for you. But I'd actually go in with like a stopwatch and like a piece of clean room paper and like write down the times, and then go back to my computer and type it into Excel and have it calculate out all the different times of things. So that really helps you understand everything that's going on, and you can observe everything that's happening, right? So what you end up doing is you break down these steps into like sub-steps, essentially. So the first step, let's say it takes 2 minutes total time, but within that 2 minutes, 30 seconds is it of him opening the bag, right? And then it takes him 45 seconds to walk from station 1 over to station 2, and then 45 seconds to walk back from station 2 to station 1. So it takes him a total of 2 minutes. Right, step 2, where he's sorting the candy, takes 5 minutes. All he does is stand there and sort candy. He doesn't have to move anyplace else. But essentially, it takes him 1 minute to do each different candy type, on average. So in this situation, because it's a manual station and a person doing it, right, you'd have to go in and time all the different people that run this station to come up with some sort of average time that it takes to really get the variability in, the human variability. Right, so then we move to step 3. We're going to say step 3 takes 10 minutes. He's now a lot closer to step 2, so it only takes him 15 seconds to walk between his station and station 2, but he can only pick up one candy type at a time. So he has to do that back and forth 5 times for each bag, right? So that equates to 2.5 minutes. Then it takes him 1.5 minutes to count out each type into the different cups, making sure there's only 5 in each cup, right? So that takes 10 minutes. Station 4, it's pretty far away, right? And all he has to do is walk back and forth. But once again, he can only pick up one type of candy because we can't have cross-contamination. So to do a bag, it takes him 10 minutes. Because it takes him 1 minute to walk over to station 3, grab the bag, to walk back 1 minute, and walk back 1 minute for the next one back, because there's 5 different types of candy. Right? So, with that in mind, did anybody see any ways to improve that process right off the bat?
You could create a lid on the cup that would prevent cross-contamination, so you, in theory, could take more than 1 cup at a time, possibly.
Mm-hmm. Yep. That's good. Back there?
You could switch 2 and 3.
Yep. Put them in order.
And maybe instead of having 3 go get the stuff from table 2, group 2, back to group 3, combine them both. So when you're sorting them, you put them in the right container.
Mm-hmm.
So that means you only have 3 places to go, like 3 groups instead of 4.
Yep, that's a good idea. Combining activities and resources. Anything else?
You could have 2 go through all 3 steps, and then 2 others going and taking the candy and shipping it.
Mm-hmm. Adding people. Yep. Good. You guys hit on some of my improvement ideas. Okay, so I've grouped them into different categories because they kind of fall into different types of ideas. So we have the layout projects, right? So that's like moving the workstations, so ordering them 1, 2, 3, 4 in an order, maybe pushing 1, 2, 3 closer to 4 to just decrease the walk time between each one, right? Because that's going to save you a lot of time. We have the capacity projects, which are mostly removing the bottlenecks. Bottleneck, in IE terms, is essentially just where any sort of inventory is building up at the station. So you could see that station 2 and station 3 were taking significantly longer than station 1, right? So that means station 1 is delivering open bags of chocolate to station 2 way faster than station 2 can sort it and send it on to station 3, right? But it's sorting it faster than station 3 can count it and put it in the cups. So at each of those 2 stations, they're going to build up inventory, which is something you don't want, because that's just cause for inefficiency. You have to store all that inventory someplace before they can put it on the workstation, right? It's just it's a waste of resources. So that's removing bottlenecks. You could also design a carrier or the lid to prevent cross-contamination, right? So they can take more than just the one type of candy with them at any one time. Right? You could also automate things. You could add a conveyor belt between the stations so they don't have to walk at all. You could add robots and or machinery that just does it faster than a human could, right? You just program it in and it sorts it all for you. Right, so any of those sorts of things can help in this problem, right? But then you have to think about your constraints. Like I said before too, part of your job is making sure you can actually do it. It's not too costly. And there actually is like a return on investment for what you want to do. So if you don't have money for the automation stuff, then you have to go more basic, right? It's maybe not worth it to your company. So my first option for fixing it. So now I'm in implementation. So I've decided on which of those ones we talked about before I might try to implement. And like, this is what I came up with. Right, so I put the stations in order. Now there was a constraint that I couldn't move 1, 2, 3 any closer to 4 than it was already. Right, there's other stuff in the way. It was just too costly to move all that stuff to shift things over. There wasn't a good return. So now these 3 are 15 seconds apart only, and they're in order. So station 1 now only takes a minute, right? 30 seconds to open the bag, and then 15 seconds each way to walk back and forth between station 1 and station 2, right? I added a robot to station 2 because he can sort way faster than a person. So it only takes him 2 minutes to go through.
How would the robot sort candy if it's all in one pile? You would have to sense each candy type.
Yeah, you can scan the barcode or something.
Oh, no. Okay.
But he can do it so much faster, so it's 2 minutes for him. Right. Then station 3, we're gonna give him a cart that can segregate out the different types of candies, so he can just walk over one time to get all 5 different types, carry them over to his station, and count them out, right, and set them out. And then between station 3 and station 4, this is my little conveyor belt. So station 3 just drops the cup on the conveyor belt when it's full. It sends right over to station 4. And let's say it takes that guy a minute to take it from the conveyor belt to put it in the box it's going to ship out on. Whatever, right? So, does this still have problems? Yeah. Does anybody know where that problem is?
Station 3 takes so much longer than all the other stations, since it'll build up.
Yep. Yep. Station 3 is your huge bottleneck. Right? Station 2 is a little bit, because he is going to get more inventory than he can handle. But that robot was really expensive, so we can't afford to buy a second one, so we're going to have to deal with that bottleneck. Right? So we want to make that bottleneck your one and only bottleneck in the factory. Right? You have to pick and choose your battles. So, what do we do to eliminate this bottleneck?
Add more people.
Yep. We add more stations for number 3. Right, so now it still takes 6 minutes for any one bag to get through station 3, but now there's 3 different people. So every 2 minutes, someone can be going to get more chocolate from the robot. Right, and sorting it. So now they should be just easy. They all pop it on the conveyor belt, it all goes to number 4 and it goes out. Right, so you've minimized as much as you can the bottlenecks within your factory to the extent of what you're given. Right. That's, in basic terms, what industrial engineering is. I do that on a much more complex level in my current job. So Intel semiconductor manufacturing is probably one of the most complicated manufacturing processes out there today. There's thousands of steps within it and probably about 500 pieces of equipment per technology that we need to run a few thousand wafer starts through the factory to produce the processors, right? And it's in a clean room environment, like you saw the picture of Andrew at the start of his presentation in that gown, in that garb, that environment is very expensive. So we also have to minimize the amount of equipment we want to buy, because it's about $10,000 a square foot for clean room space. So you need to really optimize that space. Right? So today I get to, for here in Oregon, come up with what technologies we should run and how much of it to maximize the equipment we currently have on the floor and to minimize the new purchases we need to make to install in, right? I mean, in semiconductor manufacturing equipment is nowadays anywhere from 2 million to 70 million per piece of equipment, right? So it accelerates really quickly if you want to add 10 pieces of equipment in that cost 8 million a piece, right? That's $80 million that you just spent. So it's a very fun, complex environment. So although those steps were quite simple, there are a lot more difficult problems to solve within industrial engineering, which helps to keep it fun and constant for me all the time. But so the different types of engineering, industrial engineering career options you can have by just getting an industrial engineering degree is you can specialize in capacity planning, which is essentially what I do today. That's just dealing with how much equipment do we need to optimize what we can produce. Layout and factory design. I did that in my first years at Intel when I lived in California. I owned the entire factory down there. So anything that was going to go into that factory, I had to prove it first. So I had to find the locations for any equipment they wanted to install, workstations, trash cans, inventory like storage racks, everything had to come through me first. Right, and then once we ran out of space in our existing factory, I got to actually design a new one. So, which is cool. We learned a lot from that. And that was the same, moving those workstations around, right, was essentially layout design. Human factors and ergonomics is safety for people, really. So it's how you stand at your workstation and do your job. When you're sitting at your computer, you should be sitting up straight, arms at a 90-degree angle. It also falls into safety clearances when people are doing maintenance on equipment. So you can specialize in dealing with all of that stuff and become kind of more like a safety engineer. Risk analysis and decision. My girlfriend works for an insurance company and has been doing risk analysis for them ever since she graduated with her IE degree. So she helps them decide whether the insurance company should insure the building or that company. Right. And then quality control, like we talked about, not contaminating the different chocolates. Right. So all these companies and many, many more hire industrial engineers. I tried to come up with quite a variety of different types of companies that you could work for, but all of these need some sort of logistical processing efficiency work done, and especially healthcare is huge. Nurses, how they do their schedules, how many nurses they have on hand at any one time in an emergency room. There's lots of college projects towards healthcare for industrial engineers. And UPS, you're doing mostly logistics, where should they have warehouses to hold packages? How should the truck be loaded with what packages to where he's going to minimize fuel, maximize how many packages he can deliver in a day, all that sort of thing. So then what puts engineering apart in college, just so you know, is typically you're going to have to take more statistics than any other engineering class, because it is a lot of statistical probability based to make your decisions. We take accounting, economics, have to do communication. That's kind of why this is the business engineering blend. So you do, if you are enjoying business, you like math and science, you might be the way to go. And then the last slide is just why I think you should be an engineer. If you enjoy these things, so making things better, working with other people. Because in that example of making that process line more efficient, you have to work with each one of those people to figure out how are they doing their job, how could they be doing it better, how you can help them. right? And then getting them all on board with actually implementing all those changes, because people don't like change, right? And if you like to save money and organize. But, so that's all I have to say. Does anybody have any questions? I have chocolate for any questions. I answered everything?
Was there like a certain after-graduate degree that you would need for that?
Nope. To work in my current group at Intel, you do need a master's degree in industrial engineering. But to work for Intel in general, you do not need that. And lots of other places don't require a master's.
Does your job send you anywhere? Do you have to travel?
I do not in this current role. Some of the folks on my team that specify more on the layout functions will go to some of the other Intel sites, because we do help. We are the technology development group here, so we do help when they're starting up a new technology to lay things out and place the equipment correctly within their sites. So.
How did you find places to intern for?
Usually your college will have an engineering career center that a lot of companies will actually come to the college and interview you on site. I happened to get into Intel because my aunt used to work for Intel in California, which really helped. Because even looking for an internship, lots of places want you to have experience. So if you know anyone in any company that you would maybe want to work for, or maybe even not, but you can handle working there for 3 months, you might want to do it just to get some experience on your resume. Then it was way easier to find the second one. But I enjoyed my first one so much I didn't look for another one. But I interviewed at Miller Brewing originally for my first internship as well. But career services can help a lot.
I'm not sure if you just answered this, but do they take high school internships or no?
Not that I know of. Because they still want you to have some engineering courses
So they don't have
completed.
any programs for high school students?
Not that I know of. Any other questions? I know it's almost lunch, so everybody has to go. I understand that feeling. All right.
What does your day look like day to day?
Mm.
Sit at a desk, have nothing but meetings.
My day is mostly at my desk or in meetings now. When I started and I was mostly doing layout stuff, I was in the factory a lot and away from my desk just working with everybody. So like I said, I dealt with anything that had to do with the factory, so watching someone do their job on the workstation and figuring it out, and so I was almost never at my desk. Now I'm predominantly there because I do on the capacity side, you just do a lot more calculations of things typically, which are all kind of done in Excel or some sort of database program. So I mostly work on that stuff now.
I have my own. Ah. Okay, thank you.